Hello! You've been dabbling in game development for a little while now and finally decided to start your own project. You've got some code, quite a lot of code actually, and something might be bothering you. What if you're being held hostage by French-Canadian terrorists and a rogue bullet strikes a 55-gallon barrel of poutine sauce, submerging your laptop in brown gravy and destroying your hard drive and all of your work on it? Or what if you and your friend are working on a project and both of you have, foolishly, made changes to the exact same file? Or what if your coworker goes mad and has suddenly begun to turn your game into a fan remake of 2024 adverslop shooter Funko Fusion? I guess you just lose everything and start again, right? Wrong. Please just learn how to do version control. I'm really tired of seeing Reddit posts where people have lost their entire game because they just didn't back it up in some way. And version control is the best way to back up, as well as do a lot of other things too. Version control systems like Git, Mercurial, and others can be used as backups. They can be used to integrate work between multiple team members, can manage releases, can be used to track down who wrote what code and why, and much, much more. Every serious programmer uses version control of some sort, and it can be complicated, but the basics are so easy to pick up that I'll be able to get you set up in a few minutes here. I've made two versions of this. One simply shows how to get set up with Git in a very simple flow that will essentially function like annotated backups. And the second one that's in a lot more depth and will cover some more advanced workflows like for collaboration and such. You're watching the long one, so let's get started. Version control is any system that helps us keep track of changes in a file over time. You could use it for non-software development tasks like tracking changes in a movie script or technical manual, but we're going to be talking about software broadly and game development specifically. There are a few different version control systems that are commonly used, like Mercurial and Subversion, which have different workflows slightly and benefits, but Git is the most popular by far, and I will be using that for my examples. A quick note, you might get confused between Git and GitHub. Git is the version control system. GitHub is a service that hosts Git repository. There are several other services for hosting Git, like Bitbucket or GitLab, and the differences between these are not important at this stage of understanding. A repository or repo represents a single project in Git. For a simple app or game, you might have only one repo that stores your entire code base. For more complex projects, you may distribute complexity among many repos. For instance, you could have a repo for front-end code for a mobile game, and you might have a repo for the server code. As a new developer with a smaller project, we are going to focus on a single repo. If we look at a repo on GitHub, we can see what looks like a file system that has all of our current files, but that's really just the tip of the iceberg. Inside a repo, we store change sets, which we call commits. A commit can be any number of changes to files within your repo. When you commit code, Git tracks which lines have been changed and to what, and it will be associated with a commit that has a message, so you can sort of track why these changes were made, as long as you have reasonably focused commits and don't write commit messages like me. So if you look on GitHub or download a repo, you see the current state of your project. But if you look deeper, you actually have a history of each thing that has been changed in each past commit. When you view a commit, you see what was added, deleted, and changed line by line. This makes it particularly excellent for tracking changes to files that are human readable and have line-by-line semantics, like most modern coding languages, markup, and human readable serializable data formats like JSON, XML, as well as a lot of the data files that game engines create. I like Godot's scenes and resources a lot. They're very easy to read. Git can track any files. There's nothing wrong with committing textures, sprites, 3D models, and sound to Git, but unless you're one of those guys from the Matrix, the change sets of those won't be very meaningful. Very large files, like long videos, 4K textures, etc., may have restrictions or cost more for storing on hosts, but most importantly, never, ever, ever commit passwords or API keys or any sensitive information. If you need those in your game code, which you might, store them in a separate file, copy them into a local repo, and add that path to your gitignore so they are not stored in your version control. I will cover that later. Git repos can live in different states on different computers and online hosts. We can use pull to reconcile these, pulling in the latest changes from our cloud repo, and push to send our local changes up to the cloud. We'll explore how we can use this for collaboration later, but let's get set up first. To set up Git, we're going to need to set up 3 components, and we're going to speed run this so you can see how fast it can be. We need Git itself, a GitHub account, which is technically optional, but we want some sort of online service to store your repo. We want a GitHub client. There is a command line client that will come with Git, but I think newer programmers will prefer a graphical interface. Check if you have Git already. Open up a command prompt window and type git space -v. If it says Git's not found, that means you don't have Git. If it says something, that probably means you do have Git, which means you can skip this next step. If you don't have Git, you can go to git-scm.com, install Git. If you just click to download for whatever operating system you have, you can just run through the wizard. Almost all of the defaults are fine. I think you want to click on the one that says to add a bash profile to Windows. Other than that, you can just accept all of the defaults and it should work okay. And that should just install Git. You may need to reopen your command line window now, but if you do that and then type in git-v, you should now get a version number, something like this. Now let's set up a GitHub account. GitHub is the most popular Git host. It's free to start on. So just go to github.com and you can go through the process of making a free account. Free accounts have tons of options. You can still make private repos. You can still use it basically however you want. Go through those steps and verify your account. Then when you finally are able to sign into your account, it should look like this. We're going to make your first repo. You can click on create repo. We will give it a name. Doesn't matter what it is right now, but you could name it your game name. Description is good. Then the important thing here is choosing visibility. If it's a private project, please make it private. If it's public, everyone can see it and download it. So just be careful about that. The other really important thing is to add a git ignore. I think you can just search up the engine you're using or whatever framework or whatever. Use Godot, so I'm going to pick Godot here. But there are ones for Unreal, Unity, etc., etc. All the git ignore does is specify exactly what files to never put in Git. We are going to come back to this when we look at passwords. That's your GitHub account set up. Let's download a GUI client. So we can go to GitHub desktop here, desktop.github.com, and download it. This should be a really quick install that will just set up a visual desktop for you. There are tons of other Git clients, so if you prefer something else, that's totally fine, but this one's well integrated. It will ask you to sign into GitHub with your credentials. Once you are authenticated, it should have access to all of your repos, and you should be able to pull them, push them, and everything. You can see in your repositories, if you finished making your first repo, it should be there. So you can click on that, and then you can click on clone, and then that should let you make a version of that repo that is local that you can work on. Cloning the first repo, perfect. Now, what you can do if you have a game project already made, which I do, is you can just drop that folder into the repo folder. So let's do that. So I have a game project folder. There's nothing really in this game project. I'm just going to paste it in here. I think it's okay to have it in a subfolder. That's a choice you can make. You'll see all the changes that were made for this game project. And because we have git ignore, it ignores anything that is auto-generated by Godot, so it can be a little bit easier to read what has changed here. Anyways, I'm just going to make a commit here. You can type in a name for it and click on commit. And now you'll see that where it says push origin up there, there's a 1. That means you have one commit that the GitHub repo doesn't have. And then if you press that push, you should be able to go up here and you can see that all of your files are now up in Git. Now, if you go to another computer and do the same steps and then pull this repo, you will have all of that information, all of that code. All right, let's deal with stuff like passwords. You might have passwords or API keys or something like that in your repo. You need to make sure you never, ever put those onto a repo, even if you overwrite them, because the history still exists. The way to do that is to use git ignore. You can edit git ignore with any text editor and make sure you just add the name and path of your password file, and you'll see that now it does not pick up your passwords and git ignore has been updated. So you just save that, commit git ignore. Whenever you want to put this on a new computer, just make sure you have your passwords stored somewhere else that is safe, and you'll want to be able to copy your password file in manually. You might have to re-import your Godot project just because the path might have changed. That's easy enough. It should work just fine once you do fix that. Cool, and then like the power of Git here is it will keep track of any changes you make. So let's make a new script here, and you can see, I'll just call it test script, doesn't matter. and we can put some nonsense changes in here. I'll just say math equals 2 plus 2. And then if we save that and we go to our Git client, you'll see that we have some changes here. They are the script itself, plus some metadata, and also the fact that it's been added to our scene file. And then we can commit that, and we can push that, and that will be updated again in our GitHub repo. And then the more powerful thing is if you make line-by-line changes. So if we change math to be 2 plus 1, if we look at our commit history, it will only show us that. So this is really one of the big powers, is you can see exactly what gets changed from each commit to each commit. And that's really all you need to do for the basic flow of Git. You can come back later or watch the longer video I made to understand more useful collaboration techniques, etc. But this will generally save your stuff from being wiped out if your hard drive blows up. Git's a pretty safe place to store stuff. It handles code, text, and like serialized resources like JSON and XML very well. It can handle things like 3D models and textures okay. You won't get really good line diffs, but it can still store them. Very large files, like your really big 3D models, really big textures, sounds, and videos, that can be a bit of a problem sometimes. So be aware if you're making a really high fidelity project, putting up things that are many gigabytes large might be a problem. But if you're making a smaller indie game, putting up small textures and stuff is never going to be an issue. Just make sure you never, ever, 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 ever commit passwords or API keys, even if it's a private repo, because private repos sometimes do go public, or you might add people to the project, etc., and they can find those keys in the history. So don't do that, ever. Now that that's all set up, we can get into a bit more detail. In its simplest form, a Git history is just a timeline of commits. And honestly, it's fine to start there for your really small indie project. If you commit diligently with relatively good commit messages, you should be able to track down your old code and your reasoning and probably reverse problems or even find out where bugs are introduced. Really useful. However, a repo does not store your commits in just a single line. It stores them in a tree structure. And it can be a very simple tree with just a big trunk, but its true potential can be exploited by using branches. I will describe now a pretty typical strategy that I often use when I'm working with other people or even on my own if I feel very organized. We're going to call the main branch main, or the main branch. Older documentation often calls it master, but we have decided that this language has some uncomfortable connotations on account of slavery and such. First, we decide on a feature to work on. You choose how big in scope that is, but something like fix item duplication glitch, or make Mario jump, or update wizard spell selection, or things you could do, I guess. Depends on your game, depends on how much you want to work on and how long you have to work on it. More specific is usually better. We'll use the GUI for this, but I often use command line, but in the GUI you can click on current branch here, click on new branch, and then type in a new branch. This branch is going to start wherever you are on the timeline currently. So if you are out of date from the current main branch that lives in the cloud, then you will be behind on this branch. Don't worry, there are ways to reconcile this. Now, do your work. Whenever you commit when you're on this branch, those commits are not going to go straight to main, but they are going to go to this branch. This way you can save your stuff without having to disrupt the current main branch, and over a couple days while you're working on a single issue, you can resolve that. While you're working on your branch, other people might commit to the main branch, so they might start getting out of date from each other. At any time while you're working on your side branch, you can use git merge main to reconcile your changes with the current main branch. Just make sure you check out the main branch first and pull so you have everything current from the cloud or GitHub version. Then check out your side branch, merge master in. Then do your work. When you are done your work and when your issue is resolved, you can go to the main branch and merge your old branch in. Usually you actually want to create a pull request like this, and that will make a little page on GitHub that will let your other teammates look at it and make sure that you didn't forget anything, that your code is high quality, and it won't break anything else. You also have to reconcile merge conflicts if any code you changed also was changed on the main branch, which I'll talk about in a second. Once your code has been merged to the main branch, you can delete your feature branch and start again. Make sure you pull main, and now you can create a new branch for your next issue. What about conflicts? Well, when you are working on a side branch and someone else is working on another side branch and they merge into main, when you try to merge main into your branch or the other way around, you'll get merge conflicts because Git will not know which line of code is the correct one. So that is going to look a bit like this. And to resolve them, we just need to deal with the marked regions to make them correct and current. Sometimes you might need to talk to your teammates to figure out what this is supposed to do, but usually you can tell how to reconcile these. Often you just want both of the changes to be in. This can of course become painful and error prone if there are a lot of merge conflicts to deal with. So it's good to scope tasks to be pretty small so you can get them done in a few days rather than weeks and weeks. Also, it's good to merge the main branch into your side branch fairly often so that you can deal with these issues as they come up rather than a whole bunch when you try to merge into master. One last thing I want to talk about quickly is forking. Forks are actually kind of like branches, but they are on the repo level. When you fork a repo, it makes a whole copy of that repo owned by you, and you can then experiment with it, make edits, and even propose a merge back with the original repo. To fork something on GitHub, you can find a repo that you like and click fork, and now you have a new version of it. This can be a nice and clean way to work on tutorial code or to contribute to open source. So that's something you can play with too. Okay, I think those are the key concepts that I would recommend someone who is just starting out know about Git and version control. So hopefully you can bring this to your own processes, whether you're a solo developer or you're doing game jams or working on a small team. You can encourage good version control use so you don't lose your project, so you don't get confusing merges, and so you are able to actually make that damn game. Okay, good luck. If that was useful, please subscribe. I will see you next time. Goodbye.